Hello, Keith Rucker here at VintageMachinery.org. Guys, today we are back to working over here on our Stoker engine and really right now focusing on making a custom tool to put on my metal planer to be able to finish in the bottom. If you've been following along with this project, we got to the point where we're getting ready to do some planing cuts over on the metal planer. And because of a bunch of limitations in the setups and so forth that I have and what I can really do on this machine because of constraints in the envelope that I'm working in, we ran into some problems where the tool was kind of gouging in there. So we made some modifications to a new design for a new tool to go in there that will hopefully take care of some of the issues that we've had and allow us to get this job finished and moving on. So with that, we're going to get over here, get over to the milling machine. I've got my little kind of S-shaped part cut out, and we're going to actually start milling that out and machining it out over there on the 2D horizontal milling or vertical milling machine in the shop. Let's get at it. Well, I'm getting set up over here at the Kearney Trekker Model 2D rotary head milling machine. Again, this is the machine we're going to be doing some of this work on here. I chose to use this machine because we're going to be swinging some radiuses. I need to curve, make the bottom of this thing round, and I've also got some slots that have to be cut not only at my X and Y 90 degrees, but at 45 degrees across. I can do all of that on this milling machine, and you'll get to see here in a minute what I'm talking about with the rotary head on here. It's a pretty slick little machine for doing this kind of work. So anyway, I've come over here. I got a vise on here. This happens to be a original Kearney Trekker vise. And not only is it an original Kearney Trekker vise, this particular K&T vise came out of the Kearney Trekker factory in Milwaukee where it was used to make other K&T milling machines. I got this from Ron Grundy, who is my friend up there that used to work for K&T. It came out of Department 53, and he told me what department that was. I don't remember. I probably should find that out again. But anyway, I thought that's kind of neat. We're using an original K&T vise on a K&T mill. I've got the vise trimmed in. I've got my work over here in here. The first thing I need to do is I need to find the center of this shaft here, this part that we're going to be cutting on, and we're going to be drilling and boring a hole through there. I need to kind of get that figured out. That's going to be my 0, that I'll be working off of on all of my different things over here. So I need to kind of establish that point first and foremost, and then we can start doing some machining. So I'm going to go I got a touch probe that connects over to my digital readout. I'm going to use that touch probe to find the edges. We could use an edge finder. That's what I do on my other mill machine. But since I got that touch probe, we're going to use it here for that purpose. So let me go get that, and we'll do find the center of this part that we need to drill out and start machining on. So this is my touch probe that we'll be using for this. And basically you just put this into your mill, and there's a little part down here on the bottom. Whenever something touches the edge of it, you see that little LED light coming on. It will sense that very precisely just as soon as it detects any deflection in that at all. And I've already got this programmed in my digital readout with a diameter of that little ruby tip on the end to know where the center of this is and compared to that. So it will actually do my calculating for me. There's a cable that comes out of this and goes to the digital readout where it's actually not only am I working off of that light, but it's also picking it up, so it automatically indicates whenever an edge is touched. That probe touches an edge. So we'll come in here and just work off the two edges, and I'll touch this edge and touch this edge, and then it'll find the center of it in that direction. Then we'll come over here and touch off this edge. I'll probably just dial in manually 1 inch, and then that should have me in the center of the part there. Probably, yeah, that's probably what we'll do. We'll just do it in 2 separate steps, but find the center of that, and then we can drill our hole and start boring that hole that goes through there. So I've got my DroPros digital readout up here. I believe this is the model EL700, and it's got some pretty cool features in here. Again, that touch probe coming into it. So I'm going to go into my probe functions, and we're going to go over here to the measuring one. I'm going to choose this one here. I'm choosing 2 outside measurements. I want to measure between those outside measurements. I'm going to go into that mode. Now it's going to ask me which axis do I want to do this on, either my X, Y, or Z. We're going to be doing my Y axis, and this isn't very intuitive, but these arrows, you select your X, Y, or Z, but this one here is for Y, so I'm selecting my Y. And now we're just going to go to our starting position, and whenever I touch off on that, it's going to automatically come over here. It's going to recognize that it touched off on it, and then I'll go to my second position, and it will give me a measurement between those two, and then I can use the half function to find the center. So I'm going to show you down here on the part. We'll drive to our first part and then drive to our second part, and then it'll tell us where we're at. So let me show you what we're going to do. All right, so I'm just going to take this over to the edge. I'll drop my part down, and I'm going to bring it back, and whenever it touches, you'll see that little blue light and you'll hear a beep. All right, I don't know if you heard the beep, but it detected that. Now, up on my digital readout, it's just telling me to go to the in position. So I'm not going to show that, but just trust me, that's what it says, to go to the in position. So we'll come over to the other side. Drop that back down and drive that in until it touches. Right there. Okay. Now let me show you what we got up here on the DRO. So it's telling me that it measured 2.1527 inches between those, and that is actually the distance, including the diameter of the ball in this case, but it's not going to matter because it'll half out. They'll divide themselves out when we go to the center. So I'm just going to hit the half function here. Notice over here on my coordinates, it's going to tell me I need to move in 1.1304. So I'm just going to take that y to 0. Too far. It'll start beeping when you get close. Right there. So I am on the center of my part. And it's actually already zeroed out that axis over here. If I exit out, and exit out again, you notice my y-axis is on 0. We are in the center. So we've already got that one. I'm going to do the same thing on the end, but in this case I'm just going to measure off of one end and move in the 1 inch. And then we should have the center on the x-axis. So for the x-axis, it's very similar to what we just did before. I'm going to go in here, but instead of measuring between 2 points, I just want to go into the datum function. In this case, I'm going to select the x-axis, and this, let me lower my probe down, but it will go over and it will, excuse me for walking in front there, it's going to find it whenever we go in there and touch off. Right there. It found that. I'm going to exit out. And I'm going to take it to 0. Right there. Let me show you what's going on down below. So it found the edge of this, but it's looking again at the edge of that ball. That ball on there is 125 thousandths. So I'll just go in half of 125, that's an eighth of an inch. We'll go a 16th of an inch. We'll go in 62.5 thousandths, and we'll be where we need to be. So let's go to the DRO and we'll do that. So let me get out of here. I'm at 0 right now. Again, I'm going to go into 62.5. And this is only going to go in 2 10,000ths of an inch increments, so that's going to be it right there. I'm just going to zero that out. I'll zero out my x-axis, and we are where we need to be. Or close to where we need to be. So I'm 0 on the edge, but I really want the 0 to be 1 inch in, so I'm going to go in, again, I'm just going to dial that in by hand up here. I'll just go into 1 inch. Right there. Now I'm going to zero that out again. So now we're at 0, 0. I'm right in the center of that where I want the center of that hole to be and for us to work off of. So now we've established our place to work off of. Now we can get started machining over here. So the first thing I need to do to replicate this hole here, this setup, is I need to have this hole bored out. That's 1.25 inches in diameter. I'm just going to start with a hole through here. I think that's a 3/8 drill bit I got in there. And once we get that done, we'll start boring it out to size or drilling it out to size. Whoops. There we go. We'll just come down and get our hole started there in the center. And we'll just drill all the way through there. All right, we are through that first hole. Go get a larger drill bit, and we're just going to keep on expanding that hole out until we get to where we want it to be, 1.25 inches. All right, I got my speed slowed down, about 350 RPMs, and we've got a 7/8 inch drill bit that we're going to run down through here and just enlarge that hole out a little bit. All right, we are through the bottom. I'm going to pull that out. Get those chips out of there. And we'll come up with what we're going to do next. I don't know if I can go a little bit bigger on the drill bit. I don't think I got one that goes up to 1.25 inches. We'll probably have to bore the last little bit out. Well, guys, I've honestly come to a little dilemma here and been trying to kind of debate on how I want to go about from here on out. I need to enlarge this hole. I've basically got it drilled out to 1 inch, and I need to go to 1.25 inches diameter. I don't have a drill bit that I can put in this particular machine because I've got some limitations. I do have 1.25 inch drill bits, but they're big shank or, well, actually they're taper shank. And this machine I can't put a Morse taper into. I don't have anything to be able to fit one into. So that's not an option. I don't have like a reduced shank 1.25 inch drill bit that I can fit in a regular drill chuck. So my plan was I was just gonna use a boring head and bore this thing out like I would normally do on any mill machine. Problems there though as well. My boring heads that I have all have, or most of them have R8 spindles on them that go like in my Bridgeport type, or I've got a Wells Index, but it's an R8 collet. And they're fixed. They're not really removable or not easily removable. So, you know, that's not an option to put one of these in. I do have 2 small boring heads that just have a shank on the top, but the one that might be big enough to do it, it's got about a 1 inch diameter shank, and again, I'm limited on my collet size on this machine. This machine here will only take a collet up to 1/2 inch. And I don't have any larger adapters to hold larger stuff or whatever for this machine, because this machine takes a very unique collet that kind of looks like this. It's a, what is that, a 30 taper, I think? But it's a modified 30 taper. It's unique to this machine. This is the only machine that I'm aware of that uses this type of collet. They're kind of hard to find them and everything else. I've got a pretty good collection of collets and stuff that goes in here, but I don't have something that I can put a boring head on. Actually, I do. I have this one right here. In fact, let me zoom in. I'm going to show you this. So this is the top part up here is a type of collet. Again, it's a 30 taper, and you got little slots on the side that allow you to be able to put it in there. And again, it's pretty unique. This one is one that's set up that you could put a boring head or something like that on. It's got threads on it. But the threads are 7/8 inch diameter, 8 threads per inch, which is a standard thread size for 7/8. And you can get boring heads that will screw up on a 7/8 inch stud, but they're all, the ones I've found are all threaded for 7/8, 20 threads per inch. So this thread's not going to fit up onto a regular head. So probably what I'm going to need to do is make a new one of these that has the threads that I can put a boring head on. That's something I need to probably do at some point in time, because I'm going to have a need to put a boring head on this machine again in the future, I know. And right now, I just don't have the right magic combination to put a boring head on here without spending a lot of time and even some money to buy a boring head that will fit up on here. I'm taking the time to make one of these. I could do it, I need to do it, but right now I need to get this job done, so I'm not going to stop and do that. And I got another option that we're going to do, I think. So the way I think I'm going to go about this is we're just going to put a end mill in here. I've got a 1/2 inch diameter end mill. That's a long end mill that will drop down in this. And because this is a rotary head mill, basically I can rotate this spindle out to a diameter and do a complete circle. I can just come in here and just use this end mill to just enlarge that out until I get the 1¼ diameter. Maybe not the most efficient way of doing it, but hopefully it'll get the job done. I think this will work. We can put this end mill in there. I got a collet that'll hold that size end mill. So that's what we're going to try. Let's give it a shot and see how it goes. I think first thing I'm going to do is kind of clean things up from my drilling, and then we'll get this set up and try to use the rotary head feature to enlarge that hole. So I've got my spindle locked. We're going to go ahead and change out this collet. I've got a little collet wrench here. Loosen that up. There we go. And the way this works is there pops out that collet. So now I'm going to get the right one to go back up in there. Let me grab it. I said a while ago that this thing will take up to a 1/2 inch collet. Actually, it'll take up to a 3/4 inch collet. There's two different types of collets. There's this one here, the bigger collets, and then I've got some smaller ones for the smaller sizes that go in an adapter. But we're going to just use a 1/2 inch right now. That's what we're going for. So let me get the end mill in here. And the way this one works is there's two different caps. One of them has these slots in here that allows this cap to fit up over those little slots right there, and then you capture it up underneath the bottom. However, when you're using these collets here, there's a separate cap that actually has a collet closer on the bottom that you screw up in here to hold those on. So there's two different types of the collets that fit up in here. This one is a 1/2 inch. And let's go ahead and tighten that up. All right. I'm going to unlock the spindle up top, put this stuff up, and we'll get in there and see if we can open that up. So we're about ready to start our side milling. The first thing I want to do is drop my end mill down in here. There's a little lever here on the side that operates the quill. I'm just going to go ahead and get that down. I'm going deeper than I have to, but I want to get as close to the top up here before I start having any interference with the vise down below. That's about where I probably need to be. Now the cool thing about this rotary head mill is that this whole top part up here will rotate around in a circle, and I can actually move the spindle from the center. Right now I have it set on center, so that it's right in the center of this circle, but I can move it out and swing an arc, swing a diameter. And you do that by just turning this handle right here. Oops, I want to go the other way, but that's actually moving the cutter out. So what I'm going to do is I'm going to turn on my spindle. We're going to come out there until we just touch, and then I'm going to rotate the head around in a circle, and we're just going to slowly enlarge that hole and kind of eat it out. That's my game plan. Let's see how it goes. Got my spindle speed set to about 1500 RPM. And like I said, I'm just going to bring that out until it starts touching back there in the back. Right there. And now I'm going to rotate the head around. Looks like we may be off center just a little bit. I was just barely touching there. from the hole, but we will redefine it on 0, 0, which is where I want it to be at. All right, I'm going to feed in a little bit more. And we'll rotate around again. Hey guys, I made a little change here. I went to a 3/4 inch diameter end mill and just have a little bit more beef in that thing. I'm going to come back out and touch that off again. I'm going to try this out. I've got my speed slowed down to about 800 RPMs. That seems to be cutting better. I'm getting a nice looking chip out of it anyway. We've got cool mist going in there now. So that's we did another 10. Roll around. So I got the measuring on this little shoulder bolt that fits down through here, and it's actually a little bit undersized, and our hole's just about 5/1000 undersized, but that fits just fine. So we're going to stop right there. I think we are to where we wanted to be. Like I said, the hole's about 5/1000 undersized, but it's a good fit, and I'm more after a fit than I am hitting a number precise in this case. So I'm happy with that. So next step is I want to kind of make this where this can recess down in here a little ways. So, you know, want to mill out a round plug for the top of this to kind of drop down into it. So we'll just use the same function that we're doing now, but we're not going to go the full depth, but we're going to continue opening that hole up in the top. I need to figure out how deep I want to go, and we'll just continue opening it up. All right, so again, I want to enlarge that diameter. I want to go about 3/4 of an inch deep so that this will recess down into that block. So what I'm going to do is I've moved my cutter back just a little bit. I'm going to drop that down till it touches right there, and then I'm going to set my 0 on my depth back here in the back. All right, so we're going to drop this down now to about 725 thousandths. So that's 1, 2, 3, 4, 5, 6. That's 700 right there, and we'll just go to about 25 thousandths right there. So that's just a tad under 3/4 of an inch down. Like I said, we'll clean that bottom up on the final pass. But now I want to just go in here and continue cutting that out. We're not going the full depth now. We're only going down 3/4 of an inch, but we want to continue cutting that out round. Well, everything appears to be fitting. I can drop that head down in that hole. This will drop. It's not going down because it's bottoming out, but it's going to fit. That's the main thing. I got clearances. I think what I'm going to do is while I'm going ahead and got the radiuses going, I'm going to go ahead and swing and clean out the outside edge here. I'm not going to clean out any more in the back, so I'm just going to do a half of a radius here and go ahead and finish cleaning out all of that in the back. So let me get that going and we'll get these corners cut out and move on to the next step. So the next thing I need to do is, if you look at the original cutter, there's some slots in here that this tool steel can kind of slide up and down in, and they got them at 90 degrees and at 45 degrees on either direction. I need to get those milled in there. Now back here in the back, I need to just have some clearance where this can kind of run up into there, so we're just going to kind of cut a groove in there. Let's see how far back we need to do that. So we'll just to give us plenty of room, we'll go about that deep. We're just going to cut a slot all the way down, and then we'll work on the other one. So I've got my center place saved. I'm not going to change those coordinates. We'll just work off of the axes here. I'm going to start with the long one, then we'll probably do this one here, and then for the 45s, I can actually rotate my head, and using the same feed we were doing to increase the diameter, we can actually run it in and do that angle. So let's get this knocked out. I got a 1/2 inch end mill in there, and we're ready to roll. All right, we are ready to get started here. I'm going to just do my feed by raising the table up here. I'm going to start out by just kind of getting a 0 cut there, and then we will come out. And let's just do about 25 thou on the depth. Turn on my coolant. And we just feed across. I'm just going to kind of visually stop there when I get to that back point. Quite touch there. We're close. We're touching right there. Let me I'll reset my depth on my dial back here to 0. I'm going to go ahead and make a pass right here. I need for that groove to be 100 thousandths deep off of this area, so that will become my 0. And we'll take 2 50 thousandths cuts to get us to the total depth. All right, so I'm going to do a 50 thousandths. Cut across that. Come back out. Make one more pass, and that should make that 100,000 feet. Now this should be the final pass on this axis. All right, that's far enough. And I'm going to go to my 0 on my digital readout, put me back in the center, and we'll stop there. And we'll do our y-axis next. I'm I'm gonna lock down my table right there on the Y-axis. And we'll just cut across, and I'm gonna do this one by hand, so I'm gonna just go slow and do the whole 100,000th, I think. All right, let me go back to 0 in the center. So to cut the 45, again, what we'll do is we can make this head travel on a axis. I got a couple of inches of travel, but I'm gonna rotate my head. Right now I'm on 0 degrees. I'm gonna rotate it around to 45 degrees. Come on. It'll be all right, that should be 45 right there. And I'm gonna lock that in. And now I can use this to travel at that 45-degree angle, and we're gonna go ahead and start nibbling down back there in the back and get that cut out. And we'll have to come out all the way out the front as well. I'm gonna be feeding this by hand, so I'm just gonna do 100,000ths on the depth. I don't have a power feed in this direction. I gotta be careful I don't run into my vise back there. All right, there we go. I'm gonna come back to the center and we'll get our next angle. So now what I want to do is I want to rotate my head around 180 degrees where I can come out this other side. I've got most of the stroke in this angle is in one direction. I can go about I think an inch or so back, but it's not far enough to go the whole way. So we're just going to rotate the whole head around. We'll just come around to 45. I want to take this off so it doesn't wrap around there. We'll just go all the way around. See, I can just use that. That should be 45 degrees back in this angle now. So we'll just come out that corner. I didn't change my depth, so this should be just going directly 180 degrees behind it. I got to get over here kind of behind the machine to crank it, but we'll just take that right out. All right, we'll go back to the center. Well, I had to take a little break there, and it was actually a day or two before I could get back, and I got a little surface rust on this, but I was able to get it finished up. We are back into the center of the part there. I think I've got all my milling done now. I do need to round out the bottom of this to get that square off of it, and I could do it on this machine with the radius and just mill it out, but honestly, I think what I'm gonna just do is take it to the belt sander and just round it off over there. It doesn't have to be that precise, and it's just gonna be a lot easier and quicker to do it on the belt sander, so I think that's what I'm gonna do. So I think we're ready to pull this tool out and take it to the belt sander, and I need to get this mill cleaned up because that mist getting the water on the table and stuff. I got a little bit of surface bloom going on right now with some rust, and I just need to get it all cleaned up real good before I walk off and leave this machine for a while. So let me get that taken care of. I think we're through on this particular milling machine. Well, I got this machine cleaned up, basically just got all the chips off of it, vacuumed it out real good, wiped it down, and then sprayed it down with some WD-40 just to put a little, displace any water that might be left on there from that cool mist system and get up any rust. The rust was just a little bloom on the surface, no big deal. But this machine is cleaned up and ready to go for the next job whenever that comes up. So let's get back over here to our part and finish getting it ready. I'm over here at the Ameribraid sander now, belt sander, and we're just gonna round off the bottom of this just to kind of make a nice radius around the bottom so that it kind of matches that top piece that's gonna go on here. So let's just go here and hopefully make short work out of this. I'm just gonna kind of come in here and start working on those radiuses on the edges. All right, I'm happy with that. All right, I did a little filing on this, just cleaning it up, deburring it, getting it ready to go, and just testing it with my high-speed steel here. So basically you want this cutter to be able to fit in here in one of 4 different ways. So it can go in there like this, go in there like this, and of course it can stick out either end, but in that direction. Then we got the crossways. It fits in that one and it fits in that one. So we can mount this where basically you got 1, 2, 3, 4, 5 positions, technically 6, 7 if you wanted to come up here, but I can't imagine there's a reason to do that. But you got 1, 2, 3, 4, 5 positions that you would mount it in. And our cap piece fits down in here nicely. So you get your cutter going through the hole there. There we go. And then when you clamp all that down, you got a nice fit. Let's see where we're at here. Just first thing I want to show, this is a piece of 1/2 inch by 1/2 inch tool steel. And I'm over here on the original one, not the one we made, but the original one. But I wanted to show this because when you put this in here and you put this tool bit in, there's a gap in the top, okay? Now you can put a shim in there and use this, but this is actually made to run 1/2 inch wide by 3/4 inch tool steel. So, and I've got a little bit of that here. So get that in there. So when that goes in, when this thing tightens up, it clamps it tight. So just wanted to show that real quick because the same thing's happening over here on this one. You really need this thicker piece of metal, but when we put this in, there we go, we got it. It's gonna clamp up just nice. And like I said, I had a couple of pieces. Here's one that's a little bit shorter, that size. I probably need to find some more to make cutters with, to use with this tool cutter, because really, and like I said, you could use a piece of 1/2 inch by 1/2 inch and just put a shim on the top to tighten it up. The other thing I'll note is that when I was making this, I purposely opted to make the back side of this a little bit thinner than the original. And if you look here at the cross sections, this is a lot thicker. But the main reason is I was trying to get that tool back as far as I can get it from a pivot standpoint. And we got plenty of meat down there to hold it. But in order to tighten the bolt up on the back, I needed a kind of a spacer or washer. So I just went over to the lathe. I mean, this is just real quick, made this. So let's just put it all together. Put our cutter in here. Of course, we need to grind the cutter to fit. This spacer go on the bottom, and then there's a nut that tightens it all up on the bottom as well. And we'll get all this going, and I think we've got it ready to go put on the planer. And just I got to get a cutter ground and everything, obviously, but I just want to see how it's going to work from a standpoint of clearances and all that. So there you go. We've got our cutter made. Well, here we go. We have this cutter over here mounted on the planer. I've got to get everything set on the stroke length. I'm just going to have to be adjusted because the cutter's moved back. And but just quickly looking at it, I think I've got plenty of clearance in all the directions that I need. Yeah, I think we're ready to take this thing for a test drive. That's going to be upcoming in another video. I got to get a cutter ground. We need to get our machine set up and then get over here and give it a try and see how it goes. Guys, this is a lot of trial and error, I know, but we're just trying to find the right combination to get this job done. Once we get this job done, I think we can really move on pretty quickly with this Stoker engine, or at least get it headed in the right direction. We've been stuck here for way too long. So anyway, we'll keep my fingers crossed that this will do. Again, getting the tool back, you know, this cutter swings up here a little bit. I got a little limiter in there right now. We're only go just forward just a little bit, but the idea is to get that cutter back so that when we get some flex in this, that the cutter is raising up out of the work rather than digging into the work. Let's see how it goes. We'll try it out here coming up real soon. Guys, with that is going to be a wrap on this episode. As always, thanks so much for watching. Please subscribe if you have not already. Thumbs up, comments, they really greatly help out a lot. I do appreciate those. Big, huge thank you to those who support the site financially through Patreon, PayPal, etc. Really enables me to take the time to shoot these videos and bring them to you. And guys, with that, I'm going to get out of here. We're going to catch you on the next video again. Thanks for watching.